This chart tracks how long it took some of the biggest tech platforms in history to reach 1 million users. Netflix took 3.5 years. Facebook took 10 months. Instagram managed it in 2.5. But for ChatGPT, that line shoots up almost vertically, hitting 1 million signups in just 5 days. And the curve keeps going. Within 2 months, the platform reached 100 million active users. By late 2025, that data point expanded to 800 million users logging in every single week. Before that massive spike, the internet operated on a specific premise. You typed a query into Google, and the search engine handed you a list of blue links supported by advertising. You had to click through, read, and synthesize the information yourself. Advanced artificial intelligence technology certainly existed prior to 2022, but it was largely confined to academic research labs. Consumers rarely had any direct experience with deep learning models. An AI that bypasses those links and simply provides the direct answer challenges the very logic of the search-based web. It meant that for the first time, users had a way to find what they were looking for without having to navigate a traditional website. The technology that enabled this shift traces back to a 2017 research paper. Ironically, the breakthrough came from researchers at Google, who proposed a new neural network architecture called the transformer. The core innovation of the transformer is something called a self-attention mechanism. Instead of reading a sentence one word at a time, this mechanism allows the network to look at entire strings of text all at once, mapping out the contextual relationships between different words simultaneously. A research lab called OpenAI recognized what this architecture could do if given enough computing power. Leadership, including CEO Sam Altman, focused the company's efforts on scaling these models up. Along with co-founder Greg Brogman, the team spent the years between 2018 and 2020 building the Generative Pre-trained Transformer, or GPT, series. They fed the transformer massive amounts of internet text, growing it into an enormous predictive engine. Yet, even with billions of parameters, these early GPT models were essentially raw statistical calculators. They were incredibly good at guessing the next word in a sequence, but they lacked the specific alignment needed to be useful for the average person. The core flaw of a raw large language model is that it only cares about patterns. It strings words together based on mathematical probability, without actually understanding human intent or the accuracy of its own output. This led to a phenomenon known as hallucination. The machine would confidently declare absurd falsehoods, like claiming that an elephant lays 5-pound eggs, or it would reproduce the toxic biases found in its training data. While monitoring the testing environment for their GPT-3 API, developers noticed something interesting. People were ignoring the technical inputs and naturally trying to converse with the software playground, treating the machine like a back-and-forth dialogue. Adding more computing power wouldn't fix the hallucinations. To make the tool public, engineers realized they had to force the machine to listen and follow specific human instructions. The solution came through a technique called reinforcement learning from human feedback, or RLHF. It was an intensive 3-step training process designed to teach the AI how to behave. This diagram outlines the method. It starts with supervised fine-tuning. Here, human testers provide the raw AI with explicit written examples of helpful and safe responses, establishing a baseline of behavior. Next, the team builds a reward model. The AI generates multiple answers to a single prompt, and humans rank them from best to worst. This creates a mathematical scoring system that teaches the AI which types of answers humans prefer. Finally, in the policy optimization phase, the AI practices generating responses thousands of times. It uses that scoring system to adjust its own behavior through continuous trial and error, eventually producing a highly aligned model. On November 30, 2022, OpenAI took this newly trained model and placed it inside a simple, intuitive chat window. They called it ChatGPT. It was a highly complex algorithm, packaged in an interface everyone already knew how to use. That simplicity was the moment the technology actually reached the public at scale. Over at Google, the launch triggered an internal crisis. CEO Sundar Pichai issued a code red, merging the company's elite research divisions to accelerate their own AI products and protect their search business. The education sector reacted just as quickly. Without tools to verify if an essay was written by a student or a machine, the New York City school system blocked the program on its networks by December to prevent mass plagiarism. Then came the legal challenges. The New York Times filed a major lawsuit against OpenAI and its primary investor, Microsoft. The publisher alleged the companies used millions of copyrighted articles to train the model, allowing users to bypass digital paywalls. These reactions revealed how established systems were largely caught off guard. Global institutions had no infrastructure in place for a machine that could synthesize and generate knowledge on demand. Since that initial release, the technology has evolved past simple text. Newer iterations, like GPT-4, operate as multimodal systems, meaning they can process and understand both audio and visual inputs in real time. These advanced reasoning models are now deeply integrated into the infrastructure of the web and daily enterprise software, powering tools like Microsoft Copilot, used by millions of office workers. The release of ChatGPT introduced an alternative to the traditional search engine. For a significant portion of the web, finding answers shifted from a manual search of blue links to a direct conversational dialogue. Society has largely adapted to machines that can simulate human writing. But as these models move from simple prediction toward complex reasoning and automated software agents, we are entering a period where software doesn't just assist with research, but begins to conduct it independently.